Morning, Mr. Chi.
Good morning. How are you all?
Good morning, Prof.
Morning. Good, thank you.
Very good. How was it yesterday? Was it very good for the first day for the conference?
We think so.
Yeah, Prof. G.
Good morning. Selamat pagi, Profesor Budi. Dan
Pagi.
very good morning to Professor Ferry.
Good morning too. So we got 75. Well, hopefully we will get more participants.
Ladies and gentlemen, welcome to the second day of IConISE and ACISE 2020. Yesterday was a very insightful and engaging day, both from the plenary and the parallel sessions. I am sure all of our participants here have been getting a lot of new perspective and ideas.
That's right, Indira. I'm so excited because we still have several speakers that will share their ideas with us today. So don't worry, there will be more insights coming your way.
We would like to say a very warm welcome to our distinguishable guests and thank you for attending our conference today. To the Rector of ITS, Professor Dr. Muhammad Asari, to the Vice Rector of Academic and Student Affairs, Professor Budi Setiono,
Dean of Faculty of Industrial Technology and System Engineering, Dr. Wawan Aris Widodo, Dean of Faculty of Engineering, Professor Agung Bowo, Heads of Department in Faculty of Industrial Technology and System Engineering of ITS, and the Head of Department in the Faculty of Engineering in the
and to our keynote speakers, Professor Wei Jia, Dr. Rerum Naturalium Val Sadikin, Mr. Doan Lingga, Professor Dr. Hendro Wicaksono, Associate Professor Ferry G,
Dr. Singgih Saptadi, Professor Dr. Aris Susati, Dr. Padono Suinyo, Dr. Dia Santi Dewi, and Dr. Maria Yasari.
Professor Wahyudi Sutopo, Dr. Rifki Ismail, Dr. Ninit Indah Arfitrida, and Professor Dr. Budi Santosa. Welcome and thank you for joining us again on the second day and last day of IConISE and ACISE 2020.
With the conference theme of Big Data Analytics, competitive tools toward smart industrial system, today's plenary session will touch more on that topic. Before we begin, we will play the Indonesian national anthem.
We are inviting all of the Indonesian audience to sing along to the song at your own home. We would like to remind everyone to keep muting your microphone throughout the entirety of the song in order to ensure comfort.
Di sana aku berdiri.
Now, to get a glimpse about the institution of the host today, we're first going to play a profile clip of Diponegoro University.
Diponegoro University has been moving ahead to be the best university in Indonesia, providing 13 faculties of undergraduate and postgraduate. Diponegoro University has graduated 300,000 qualified alumnus. Diponegoro University also establishes vocational schools to generate a ready-to-work alumnus. Holding the fighting values of Pangaran Diponegoro, such as honest, brave, fair, and attentive, Diponegoro University keeps producing excellent alumnus nationally and internationally, while also contributing in the development of knowledge, technology, art, culture, and exercise.
University now is a rising star. We have planned to become one of university in 500 world university rank. We have been continuously improving the supporting aspect such as regulation, facilities, financial system, bureaucracy management, information system, as well as quality of human resources, quality escalation of three Dharma perguruan tinggi is the primary target of UNDIP by stimulating the downstream of research outcomes that can be beneficially implemented for the society. We are also keen to improve the quantity of national and international academic publication, as well as the number of doctorates and professors in Diponegoro University.
Now, Diponegoro University has been improving in two important aspects of achievement, institutionally and student achievement. Diponegoro University has become a world-class university by being ranked 5th amongst almost 5,000 universities in Indonesia. Meanwhile, the students' achievement in both national and international scales of prestigious events are increasing. The vision to be an eminent research university is supported by the continued increase of research funding. The total research and civil service funding in 2018 is 123.7 billion rupiah. It consists of PMBP, the National Competition Research Funding, and Collaboration Research Funding. The intellectual property right becomes the indicator of significantly improved research. The patent consists of simple patent, patent, international patent, software, and invention legal letter. To support the academic process, Diponegoro University has been improving the student facilities. Thus, the students will not only get the knowledge, but also the actualization space. Academic service, Diponegoro University has built a central computerized system that includes the service for the online study plan and online registration.
Iklim kompetisi di Undip yang dalam akademik maupun non-akademik.
Didukung dengan fasilitas umum dan keakademikan yang lengkap.
Sehingga membawa Undip masuk 10 besar universitas terbaik di Indonesia.
Undip berada di daerah beragam budaya yang harmonis.
Yang pastinya Undip lebih baik.
Undip lebih baik. Bagaimanapun, Undip pasti lebih baik.
That was a video about Diponegoro University. Now, we are going to see a video of Institut Teknologi Sepuluh Nopember.
Surabaya, the provincial capital of East Java, is the second largest city in Indonesia. This city has a huge number of diversities among the people, cultures, and ways of living. Surabaya has been acknowledged for its green public open spaces. It also has successfully equalized the development between build-up an area that makes Surabaya a livable city for all.
I see Surabaya as a great city with amazing people.
Living pace here is quite slow, so you don't feel the rush of living in the city.
It's also a good place to travel around. I mean, in bus you can go in many places, or taking train on Java.
It makes me so to be in peace, so I think that is a good place for me to stay.
Surabaya is also known as the City of Heroes because of its role in Indonesian struggle for independence. Moreover, Surabaya nowadays has already become the center of businesses, commerce, industries, and education in Indonesia. One of the pioneers of education in Surabaya is the Institut Teknologi Sepuluh Nopember, better known as ITS. ITS has 3 campuses in Surabaya, ITS Sukolilo as main campus, ITS Manyar its campus vocational study of civil infrastructure engineering, ITS Jokro Aminoto as campus for Master of Management Technology. Occupying a large area of 180 hectares as its main campus, ITS has 20,000 students, 1,000 academic staff, 1,000 non-academic staff, 10 faculties, and 38 departments. ITS has various fields of study, faculties, and strategic study program which are the center of excellence. Faculty of Industrial Technology, Faculty of Marine Technology, Faculty of Electrical Technology, Faculty of Civil, Environmental, and Geoengineering, Faculty of Business and Management Technology, Faculty of Architecture, Design and Planning, Faculty of Information and Communication Technology, Faculty of Mathematics, Computing and Data Science, Faculty of Natural Science, Faculty of Vocational Studies. Study program at ITS consists of vocational program, bachelor program, master program, and doctoral program. ITS also has more than 130 full-time international students and 400 international student mobility short program, K&B program, student exchange, and other programs.
I work with many projects and many assignments, so it's helped me to improve my personal skill and also for communication skill.
There are many things that we have to fulfill, and ITS has been helping me to improve this kind of things. Besides my hard skill, I also have been able to develop my soft skill, which is important for nowadays leadership.
Also with ITS, I had a lot of opportunities to join different events for free, like the Rujak Connect Festival, which was a cooking event, something. Yeah, this is like kind of opportunities that you don't have every day, and it's funny to take part for once. Yeah, it's nice.
ITS inventing many technological innovations that have been acknowledged in various international competitions. These are several national and international achievements by ITS. ITS Central Library is in a 6-story building, with total building area 9,000 meters square. This library, more than 121,000 printed textbooks, more than 10,000 e-books, 10,000 audio-visual data, and 18,000 digital library collections. Besides providing students with the books, the library also provides students with comfort study area, like discussion area, hotspot cafe, computer rent, multi-purposes room, and Indonesia Development Information Services, which connect to the World Bank database. Research and innovation at ITS are geared towards addressing global challenges. Therefore, creative inventions are increasingly being produced by ITS researchers.
People are talking about logistics and supply chain in Indonesia. We publish papers, we are doing research on transportation modeling, we are doing research on warehouse modeling, and we also do a lot of networking with industries, with companies, and our research has been used in many companies in Indonesia.
We know that Indonesia is the second biggest biodiversity in the world after Brazil, but I think if we combine with our sea area, Indonesia will be the biggest biodiversity in the world. And we do believe that if we perform science of nature and how to utilize it, it is very big opportunity for the treatment of some disease, not only for Indonesian people, but also for the world.
Considering the fact that Indonesia has unique climate characteristics, and also Indonesia is also very well known as the laboratory of disaster, therefore a lot of issues, a lot of problems have to be solved. But this is a challenge for us. We cannot work alone. We need to work interdisciplinary, which involve expert, local or internationally. Therefore, we invite all of you to work here with us in ITS. We expect that our contribution and our work will bring ITS as the Center for Excellence in Disaster in Indonesia.
ITS has more than 180 laboratories spread over 10 faculties. The laboratory is used to support faculty and students' research and provides the opportunity to collaborate on big projects and create impactful research programs.
Institution, I think ITS has contributed a lot in terms of giving ideas and spirit, and at the same time self-confidence to our country about how capable we are.
ITS, within the next 5 years, it would be a research and innovative university. It means that ITS will be playing a big role in the region, especially in Asia. For the next long term, in 2045, ITS would be an entrepreneurial university. Means that it having a big role playing in the global world.
Come and join us.
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 Come and join with us. ITS.
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 The University of You Know.
That was the profile video of Institut Teknologi Sepuluh Nopember.
Now, we have a welcome speech by ACISE 2020 Chair, Dr. Manik Mahachandra. To Dr. Manik Mahachandra, the time is yours.
Thank you for the time, Master of the Ceremony. To our honorable guests, Rector of Diponegoro University, Professor Yos Yohan Utama, Rektor of Institut Teknologi Sepuluh Nopember, Profesor Muhammad Ashari, On behalf of Rector of Diponegoro University, Vice Rector of Academic and Student Affairs, Professor Budi Setiono, Dean of Engineering Faculty of Diponegoro University, Professor Muhammad Agung Wibowo, Dean of Industrial Technology and System Engineering Faculty of Institut Teknologi Sepuluh Nopember, Dr. Wawan Aris Widodo, Head of Industrial Engineering Department of Diponegoro University, Dr. Ratna Purwaningsih, and Head of System and Industrial Engineering Department of Institut Teknologi Sepuluh Nopember, Nur Hadi Siswanto, PhD. To our distinguished guests, all department heads of Engineering Faculty of Diponegoro University, all department heads of Industrial Technology and System Engineering Faculty of Institut Teknologi Sepuluh Nopember, all our distinguished keynote speakers and invited speakers, paper presenters, and members of the scientific board, representatives from the Indonesian government, industry specialists, and NGOs, and of course, all the participants in this online meeting room. A very good morning to you all. Assalamualaikum, Shalom, Namo Buddhaya, Salam Kebajikan, Om Swastiastu. First of all, it is a delightful opportunity for us to welcome you on the second day of this joint conference of Second International Conference on Industrial and System Engineering, IConISE, and the 7th Annual Conference on Industrial and System Engineering, ACISE 2020. It started in 2014 when ACISE was only a regional and national community event held by the Industrial Engineering Department of UNDIP, organized annually to provide a media of collaboration between scientists, engineers, and industrial practitioners. ACISE has gradually become a noteworthy international event since 2016. From these regular international conferences, there were several numbers of publications in the international conference proceedings and also international journals. This year is special because Industrial Engineering Department of UNDIP is honored to organize the ACISE together with IConISE from the System and Industrial Engineering Department of ITS. So the two reputable institutions can do harmonious collaboration and give our best contribution for the industrial and system engineering community worldwide. Under the theme of Big Data Analytics, a competitive tools towards smart industrial system, the number of paper submission in this conference has reached 206, which is exceeding our projection. This has shown a great interest for this event from the community of industrial and system engineering. The scientific papers were submitted from the researchers and practitioners from the UK, Italy, the Philippines, Taiwan, Japan, Malaysia, and of course, Indonesia. To ensure the quality of each submission, we had run the double-blind review with 2 or 3 reviewers. On behalf of the committee, I would like to appreciate all the hard work of the review board members. Finally, 149 papers were selected, among others, to be presented in this event, or equivalent to a 27% of rejection rate. All presented papers will be published in the IOP conference series, a Scopus Index proceeding, or the IPTEX Journal of Proceeding series. Several high-quality selected papers will get the chance to be published in the International Journal of Applied Science and Engineering, a Q3 journal, and in the Operation and Supply Chain Management, or SCM International Journal, a Q2 journal. This year, we have privilege to have 5 exceptional speakers as our key conference keynotes. Yesterday, we already learned so much from Professor Wei Jejia from Shanghai Jiatong University, China, Dr. Rerum Naturalium Val Sadikin from Philip Eindhoven, Netherlands, and Mr. Doan Lingga from Traveloka. Then today, we will have Professor Hendro Wicaksono from Jacobs University of Germany and Associate Professor Ferry D from Edith Cowan University of Australia. Please accept our warm welcome and gratitude for sharing the precious knowledge and experiences. We also like to welcome our 9 invited speakers in this conference. Professor Budi Santosa from ITS, Professor Aris Susanti from Undip, Professor Wahyudi Sutopo from 11 Maret University, Dr. Patdono Subiknyo from ITS, Dr. Singgi Saptadi from Undip, Dr. Maria Anityasari from ITS, Dr. Rifki Ismail from Center of Excellence for Biomechanics, Biomaterials, Biomechatronics, and Biosignal Processing of Undip, Dr. Dia Santi Dewi from ITS, and Dr. Ninit Indah Arfitrida from ITS. Thank you for sharing your experience in these current issues. Also, we would like to express our appreciation to all presenters and participants in this event. We hope that you will have a fruitful conversation and knowledge sharing throughout this conference. Even though the conference is held in an online basis, we hope that all of us can still enjoy every single moment while staying safe at office or home. Last but not least, I would like to say thank you to all the organizing committee members who had put so much effort to prepare this important event in the midst of pandemic situation and all the travel restrictions. Hopefully, this event will become a memorable cooperation for both institutions and continue with another future partnership. So without further ado, we shall begin the second day of IConISE and ICISE 2020. We sincerely hope that all the participants will enjoy this conference, and we are looking forward to see you again in the next IConISE and ACISE event. Thank you. Wassalamualaikum. Om Santi 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 Om.
Waalaikumsalam.
Thank you to Dr. Manik Mahachandra for the speech. Now we would like to invite the Honorable Vice Rector of Academic and Student Affairs of Diponegoro University, Professor Budi Setyono, to give a speech. To Professor Budi Setyono, the time is yours.
All right, thank you, everybody. Assalamualaikum warahmatullahi wabarakatuh. Very good morning for all of you, dear all distinguished delegates, speakers, and especially our colleague, Pak Rektor ITS, Professor Muhammad Ashari. It is a great pleasure to give the opening speech at the second international conference on industrial and system, IConISE, and the 7th annual conference on industrial and system engineering, IC 2020. And on behalf of the Diponegoro University, we warmly welcome you in our campus virtually in Diponegoro University. It is a great honor for us to have all distinguished guests from worldwide and all around Indonesia to attend this joint conference. The conference is held by Department of Industrial Engineering from 2 top universities in Indonesia, namely Diponegoro University or Undip, that located in Semarang, Central Java, and also Sepuluh Nopember Institut of Teknologi ITS, that located in Surabaya City. Ladies and gentlemen, this conference offers a platform for researchers, academics, industrial partners, students, and also practitioners from all all over the world, whom are invited to take part in development and innovation in the area of industrial system engineering. And as a higher education institution, UNDIP collaborates with ITS in development of our nation characters through science, technology, and also other products. UNDIP has commitment to support and develop research and the application to be an outstanding research university in the future. Some of research that related in this topic, we already conducted several occasions and also areas, including, for example, the application of green manufacturing for local batik small medium enterprises, analysis of eco-efficiency in timber manufacture by life cycle assessment method, development strategy in green port environment, e-business cluster development for manufacturing small medium enterprises, the impact of value congruence, brand distinctiveness, brand social benefits, brand warmth, and also memorable brand experience to the customer brand identification. So there are also other researches that currently undertaken by researchers from Diponegoro University, that some of the result of the research will be presented in this conference. In this occasion, we would like to express our gratitude to our distinguished keynote speakers, especially Professor Wei Jia from University of Macau, China, Associate Professor Ferry Ji from Edith Cowan University, Australia, Professor Hendro Wicaksono from Jacobs University, Germany, Dr. Val Sadikin from Scientist IoT Security of Philips, Eindhoven, Netherlands, and also John Linga, Head of Data Analysis from Traveloka Group. We also thank to all participants and invited guests who will present their research papers, and looking forward to having your contribution on all aspects of this conference, that we hope this conference will facilitate the formation of networks among participants and all wide researchers in the conference topics. My best wishes for opening this conference, and I wish you all in fruitful and productive discussion. Thank you. Good morning and assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you to Professor Budi Setiono for your speech.
Now we are going to invite all of the participants to take a group picture. Please turn on your camera and smile for the picture. Since there are 5 slides that we're going to take the picture of, we're going to start with slide 1. Slide 1. Smile. 1, 2, 3. Nice. The next slide, please. Slide 2. 1, 2, 3. Next, slide 3. Show us your beautiful smile. 1, 2, 3. Slide 4. 1, 2, 3. And last but not least, for slide 5. Show us your happiest smile. 1, 2, 3. That's great. Thank you, everyone.
Next, we'll get into our first plenary session of the day. It will be delivered by Professor Dr. Engineer Hendro Wicaksono from Jacob University, Germany. He will share with us the role of data management and analytics in Industry 4.0 ecosystem. We would also like to invite Professor Dr. Aris Susanti as the moderator of this session. Professor Dr. Aris Susanti is the Secretary of the Magister Program of Industrial Engineering and Management of Diponegoro University. The Professor Dr. Aris Susanti, the time is yours.
Okay, thank you very much. Thank you very much. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Welcome to the second day. Okay, welcome to the second days of the conference. Today, we would like to hear the presentation from Professor Hendro Wicaksono. But before that, I would like to share or to read the short curriculum vitae from Professor Hendro Wicaksono. Professor Hendro Wicaksono received the bachelor degree from ITB Bandung from Teknik Informatika, master degree from Universität Karlsruhe, Germany, and doctoral degree from Karlsruhe Institut Teknologi from Mechanical Engineering. He is currently a professor of industrial engineering with the Jacob University, German. He also a head of research group of intelligent data management in Industry 4.0, Jacob University. From 2018 until now, he actively became a visiting professor in several universities in Indonesia and also in the world like the Bulgaria and Moscow. In Indonesia, Professor Hendro became a visiting professor at UNER, ITS, University of Nahdlatul Ulama Surabaya, UIN Yogyakarta, UIN Malang, University of Muhammadiyah Malang, and Unisma Malang. Professor Hendro has professional experience as the board of commissioner and advisor of digital startup and also IT consultant. The other professional activities, Professor Hendro becomes an expert panel of research foundation funder, European Material Modeling Council, and also advisor in the Hub Startup Community Berlin. Professor Hendro actively to participate in international conference, such as International Conference on Electrical, Electronic, and Information Engineering in 2019, and also IEEE Conference on Energy Conversion 2019, and many more. Okay. Today, the topic of the presentation of the Professor Hendro is about the role of data management and analytics in Industry 4.0 ecosystem. In this presentation, Professor Hendro will introduce the technology associated with the fourth industrial revolution, which rely on the concept of artificial intelligence. Professor Hendro also explained how data can revolutionize the business by providing the global access to physical product, and also will provide project example in the smart city, healthcare, and agriculture sector. Finally, the Professor Hendro will discuss the implication of the introduced concept on the Indonesian context. So it's very interesting, I think. So Professor Hendro, you have 40 minutes for presentation and 20 minutes for question and answer. And the participant in this room can ask the Professor Hendro by writing the question in the link that you can see in the chat box. So for the short time, Professor Hendro, you can start your presentation. Time is yours. Thank you.
Thank you, Professor Aris Susanti. Can you hear my voice clearly?
Yes, I can hear your voice clearly.
And also the slides?
Yes, I can see your slide.
Okay. Then, so, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. So first, I want to greet the Honorable Rector of Undip, Professor Yos Johan Utama, is represented by Professor Budi, and then Honorable Rector of ITS, Professor Muhammad Ashari, and respected faculty members of Undip and ITS, and also Honorable Conference Chairs, Ibu Dr. Manik Mahachandra, and Ibu Dr. Ratna Sari Dewi. Thank you for the opportunity to invite me as a keynote speaker in this conference, and also, of course, distinguished speakers and guests. Today I will share about our research and also experiences in data management in the context of Industry 4.0 ecosystems. So this is the outline of today's talk. First, I would like to introduce our university and our research groups. And also then I will start with the some introduction about what are the technologies of Industry 4.0 and what is the ecosystems and how the Industry 4.0 technologies implies the business model. And then I will talk about the data management and analytics, which is as the core of in the ecosystem of Industry 4.0, and some project experiences, research and industrial projects, and some implications on Indonesia. So I came from Sidoarjo, East Java, and I have multiple background, informatics, electrical engineering, and mechanical engineering. And now I'm active in industrial engineering, and I also have both academic and industrial backgrounds. So a little bit about our university. Jacobs University is located in Bremen, Germany. Is northern Germany. So maybe you're familiar with the tobaccos. So Bremen was a central of do you call it auction of tobaccos and the raw materials for textile back 100 years ago and until 2010. And now Bremen is quite famous with the logistics and also robotics industries. So our university is quite small. We have around 1,500 students only, but they are from different countries, like 120 countries. We have students from big countries like China or US, but also we have students from smaller countries like, for example, Mauritius or Eswatini and so on. So our university is international and interdisciplinary. We have a lot of interdisciplinary study programs like global economics and management, for example, and supply chain management. I'm active in industrial engineering and management, and also supply chain management, and also data engineering. And we have we focus on the research and innovation. That means we have several startups that's founded by the students with the mentor of the faculty members. And we have quite a high percentage of professor, lecturers, and researcher. Although we don't pursue ranking, actually it's typical in German university that we don't pursue ranking, but according to the THE university ranking, we perform quite well. So we are in the top 10 of small university, having students less than 5,000, and top 30 of world's young university who has less than 50 years of age. And our ranking is quite high also in top ranking in multi-rank and CHE ranking, which is the local national ranking, which is usually used as the basis for giving funding from the German government and also industry. And about our research group here. So you can see here also that our research group is quite multicultural. We have members from Europe, from Indonesia too, from Asia, the Americas, yeah. And we also have students from bachelor, master, and PhD level. So our research focus on the data management, which consists of data integrations, data analytics and machine learning, ontologies for knowledge representations, semantic enrichment for visualizations and human-centered technologies, and also innovation and technology management. And the application area, you can see here, supply chain, smart cities, constructions, and agriculture. So for those who are interested in doing PhD or research collaboration, you can then contact me.
Ya Allah, gitu kok.
Yes. Now let's go to the main part of this presentation. First, about the Industry 4.0 technologies. So I think most of you are already familiar with the concept of industry, or with the definition of Industry 4.0, which is the fourth industrial revolutions. I want just to highlight what is the difference between the Industry 3.0 and 4.0. So in Industry 4.0, the computer technologies were introduced in the industry. For example, the CAD software, for example, and also controlling systems or production planning and control system, for example. So it makes that the production and product more precise and efficient. That means before introducing the technologies like CAD, so like people draw the design of car, for example, manually using hand, and by introducing the CAD in the context of Industry 3.0, the design of car, for example, is computerized using computers, and it's more precise. And also by introducing the production control systems, so by using computers, so the production process will be more efficient, error-free, and so on. So, and in Industry 4.0, so the technologies that introduce and cause the transformations of economic and social is first digitalizations. That means this to have digital representations of almost every physical things, and the interconnections between things, not only between the human but also between machines. So these both digitalization and interconnections make this Internet of Things, service, and people. And then also intelligence. This means the artificial intelligence. So the transformation that is done in Industry 4.0 is to make the product and production more global and smart. So global means that product and production can be accessed anywhere and can be done anywhere. And the product, smart product and global product, means that the product can also access from everywhere. So of course, this transformation needs time. So to have this perfect transformation, we still, even Germany, still need time. So what are the Industry 4.0 technologies? I classify the technologies into three layers here. The infrastructures and interconnections, which are IoT, blockchain, and cloud computing. So IoT here is IoT and blockchain is about the communications, and cloud computing is about storing the data. So that means IoT collect the data, and then cloud computing store the data. And then the intelligence layer, which is big data analytics and machine learning, who is responsible for extracting knowledge pattern or higher abstraction from data. And then reasoning and searching technologies is used for getting recommendations, getting information to help the decision making from big data or machine learning results. And then on the top is the advanced and multimodal interaction. It's about the interaction with between machines or with humans. So here, like augmented reality, virtual reality, and mixed reality. And advanced robotics. Advanced robotics here means focus on the robots that can collaborate with human, not the robots that substitute human. So as I mentioned, that artificial intelligence is one of the core technologies in Industry 4.0. And what is artificial intelligence? Is subfields of computer science or informatics that focus on the mechanism that mimic the intelligence behavior of human. So intelligence means that that the technologies simulate the smart behavior of human. Smart, not the usual human, but smart human. So smart human should have the capability of learning. So in the context of artificial intelligence, is mimicked through machine learning, and like artificial neural network is one of the popular methods for machine learning, and deep learning is a subset of neural network, which more multi-layered and with more complex computations. And smart people can also process a lot of data, a lot of information. So and also to do inferencing, to make conclusion based on this data. So that means here in big data technologies, like how to process the data that's coming from different sources, and then how to store them, to search on them, and to perform inference on them. And smart people can do interaction with other people, and also usually from with other people. And the corresponding AI technologies here is human machine interaction and machine to machine interaction, for example through IoT and AR VR. So all of these technologies, the data plays this in the central roles here, because machine learning requires data. Big data is about data, and the interactions human machine and machine to machine is about data exchange, about data communication. So we talk about the technologies. Now we talk about the ecosystems from the business point of view. So I consider there is 4 pillars of Industry 4.0 business ecosystems. So these 4 pillars are: the first is smart product. Smart product means the product that can describe itself or give the information about the state of itself and its environment. For example, here the coffee machine can give information about the states of the water, for example, and the state of the operating state, standby, on or off. And smart process or operations, for example, in the context of coffee machine, is about the process that produce coffee machines, the process that supply the components of coffee machines. It involves the interconnections between organizations and between processes. And then smart resource or infrastructure is about resources or infrastructures which helps the productions or creating the product. For example, the machines, the transport facilities, the buildings, infrastructure, and so on, which can give information about themselves. Similar to product, but this is the resources infrastructure involved in the creation of the product. Because they can give informations or exchange informations, so then we cannot avoid that we will have a lot of data. So that means the fourth pillar here is to have data-driven services, which you can provide to customer. Yeah, I will explain how to do it, or the example of it, and then also we can have data-driven service to optimize the processes. So based on these four pillars, yeah, we can transform or transfer the concept of this Industry 4.0 solutions ecosystem into different sectors, like agriculture, for example. It's the same. The principle is the same. The product in the agriculture is the crop itself that can inform about themselves. And then smart process or operation could be like connection between farmers and suppliers, and connection between farmers and market, for example. And smart resource infrastructure is like, for example, infrastructure for watering, transport, warehouse, and so on. And it's and data-driven service can be created on top of this smart PPR. So I call it also smart PPR, smart product, process, and resource. So based on this definition, this smart PPR and this data-driven service, we can implement the concept of these four pillars of Industry 4.0 in different sectors, from supply chain, health, agriculture, energy, construction, and so on. So the difference is just what is the product, what is the process, what are the processes, and what are the infrastructures. But the principle is actually the same. Like the electricity or energy, the product is the electricity itself, and the health is the product is the health, which can be monitored. It can be then there's some process who give added value or improve the health, for example. So the principle is the same. Like the construction is the product is the building usually, or built environment. So how then the implication on the business model, which is the data-driven service is added to the classical product-based business model. So here, for example, I give example on Rolls-Royce. About Rolls-Royce. Rolls-Royce is the manufacturer of airplane engine like this. So usually they just produce airplane engine, but in the context of Industry 4.0, they also provide data-driven service or additional service, which are data-driven. Like they install some sensors on the engine, and during the flights, the sensor gives data to Rolls-Royce, and then the data is used for to create a new service like real-time monitoring, predictive maintenance, and service to optimize for the optimizations of the performance of the engines. So that means to get this service, the companies who are the customer of the Rolls-Royce, for example, the Lufthansa or Garuda and so on, can also pay this service. And also in agriculture, like John Deere, who produce the farming machines, also add data-driven service, for example, for farm monitoring, and also they provide social media. So they install also sensors on the machines to get data about the condition of the soils, for example. And also in fashion industry, Ralph Lauren do the same. They also install sensor in the shops on the sports shirt and provide apps for health monitoring and early warning system if there is some anomalies in the health. So the conclusions here, the new or the transformations in the business in the Industry 4.0 context is to have product service business model, combining product with data-driven service. So that means this means that we provide or enable the global access of physical product. So that means here, for example, to the data on the Rolls-Royce engine can be accessed through internet, then can be accessed from everywhere, from global. So that means the new business model here is the to enable the global access through digital service of the physical product. So, and now how we talk about that that the data-driven service or data plays very important roles in this Industry 4.0 business. So, and now, what is the roles of data management and analytics? So these are some processes in the data management, from collecting the data, clean the data, authoring, or it's about security or privacy of the data, linking the data or integration, data integrations, process give the data more meaning or data enrichment, and provisioning, and then also back to analysis and so on. So in this presentation, I only focus on these two, data linking and data analysis. Data linking is actually including the data enrichment here. So now the first is about data linking. So imagine this is the inspiration how the data linking is used in the context of Industry 4.0. So it comes from the idea of data linking in the web. Imagine that in the web we have data resources from different address here, or different resource. For example, we have internet or information resource about city of Semarang, for example, and then information resource about Undip, and then some information resource from Wikipedia about the Association of Universities of Asia and Pacific. So this is considered as information or data resource that located in the different places, and they have actually connections actually. So semantically, these three data sources have connections. And what the connections, like this information resource is actually about the city Semarang, and it's about a university called Diponegoro University. And this AUAP is about organization. So that means the connection is that Diponegoro University, located in the city of Semarang, and has or joined the affiliations or has affiliations of AUAP, for example. And this is also that explained by Professor Wijaya yesterday. So this is called knowledge graph. So how we can link the different data sources on the semantic level, on the more higher abstraction level, through knowledge graph. So in this case, is the connection is that the unit in the city has affiliation of AUAP. On our group want to transfer into the industrial. So in this, an example of knowledge graph is DBpedia, for example, or Google Knowledge Graph. So in this context of Industry 4.0 in agriculture, we have the similar problem or the similar context, which is located distributedly. For example, we have geodata about the locations of the farm. For example, we have some product descriptions on the web. For example, we have some sensor data, soil sensor, for example, sensor that get the data from the soils, and we have, for example, logistic related data that record the transport of the crops, for example, in Excel. And we have fleet data that store the data about the fleets that transport the crops, for example. It's in accessed by REST API or web service. So by using linked data or knowledge graph here, so we can connect those data, we can link those data on the semantic level. For example, it's about rice. The product here is the rice, and the rice field is located in the field, which is explained here, and the state of the rice here that's collected from the sensor then are located here, and then the fleet here conduct the process of transporting the crops, the rice here, to the warehouse, and the data about fleets here and the data about the logistics are located here. And then, so this is the knowledge graph. Yeah. So you can, if we associate it to the smart PPR, so this rice represent the product, and this process transfer to warehouse represent the process, and the fleet is the resource or infrastructure. So usually the data integration to integrate those data, we usually have some kind of exchange format to exchange them. And this linked data or knowledge graph change the paradigm of data integration from data exchange to data linking. So that means here the data doesn't have to be transferred between locations. They can be kept in their original locations, and then we just link them on the semantic level. So now about the data analytics. Data analytics is about how we can analyze and get insight from raw data in order to make decisions. So it can be classified into descriptive. That means from the descriptive analytics, we can know what already happened. We can have a diagnostic analytics. From that, we can know why it happened. And predictive, that means what could happen. And predictive, how can make it happen. Yeah. There's this for classes or for types of data analytics. And I give example in the agriculture 4.0. So there are some data analytics that can be conducted in the context of agriculture 4.0 ecosystems. So, for example, for predictive and prescriptive analytics, we can simulate and predict and simulate which crops and where to plant to have the maximum profit, for example, and how much fertilizer is needed to have the maximum output. So now it is about the products, yeah, about the crop itself. And then we can also do like predictive supply selections, which is related to the process. And also we can do health monitoring of the machines, which is this descriptive and diagnostic analytics, and predictive maintenance of the farming machines. It's about related to the resources. And what data could be used, like machine activities from the sensors that collect the data of the soil profiles, water profiles, for example, and other data like weather, financial transaction data, and supplier data. And how to by installing sensors on the machines to have some kind of cloud platform or connect to the cloud for data analytic platform like SAP HANA or Google Cloud, or also if there's a financial resource, then we can also use or build our own data analytics platform. But for small medium enterprises, I think the cloud solutions is the best. And interaction portal, for example, John Deere here has a interaction portal, and there's always challenges to implement this. For example, who will own the data that are collected? Is it the farmer? Is it the provider of the machines? Is it the cloud provider? And that the privacy is also always the challenge. And it could also reduce the employment opportunities, because in some cases the people who work in the field will be substitutes or are not required anymore, for example. So I give you some overview of project examples that we have done in the past and also currently in the different sectors. The first project is in the sector of smart cities. So this is a project funded by European Union. So we want to build smart energy systems based on data analytics and data linking for the cities as the pilot is the city of Cambridge in UK, Seville in Spain, and small city Lisanello in Italy. So it's a typical research and innovation project in Europe that we collaborate with different countries, and also collaboration between universities, industries, and city councils, for example. So the project called DARIT. So the aim is to build a platform that facilitate the activities of citizen policymakers and energy provider in the city in order to reduce energy consumption in the cities, and also to promote the applications or introductions of renewable energy sources in the city. So this is a data-driven platform that people can share the data, and it's has a graphical user interface with a single sign-on, similar to Google. So it consists of or contain a lot of applications. It's similar to Google. If you log in with your Google ID, for example, you can choose different apps, Google Docs, for example, and emails, Google Drive, and so on. So it's like the same. And the data that they share reflect some kind of continuous or integrated process. For example, the citizens can share their own energy consumption data in the platform, and then the policymaker can use the data that's shared by the citizens to see how is the total energy consumption of the city, and then they can plan, okay, we need a new power plant, for example, and then the data also can be used by the utility companies to determine what tariff is the best for which customer, for example. So in this DARIT, we have a different level of interaction with the data, from just information do some prescriptive analytics or simulations, and then also actions or implementation. So we have this different application, like just information means, for example, like just monitoring the consumption of energy in the districts, or see the trending of the energy consumption. And simulation, for example, we can predict the energy consumptions of a building based on the materials of the building. For example, the profile of the physical profile of the building, like the number of windows, the area of the building, and so on. And we can also do simulation on the for the investment of renewable energy sources. For example, if we want to install solar panel, and how much energy we will get, and also if you want to install wind farm, how much energy and how will it cost. And also like action, we provide marketplace to connect with the energy consultant, for example, and so on. So similar to what the concept of data linking. So for this project, we have different kind of data, from CAT data, sensor data, data provided by the government, like statistical data, geodata, and data from sensor on the renewable energy sites. And those data should be linked, should be integrated, should be connected. And we create microservice layers that can provide higher abstractions of the data, and then link them using knowledge graph. And then these different apps, different applications connect to the knowledge graph. And then the knowledge graph then can route which data is required by which applications.
I'm sorry, Professor Hendro, you have your time only 5 minutes more.
Yes.
Yeah.
Thank you. So these some screenshots of these projects, like this monitoring of the Seville in Spain. And it's also like the trends of energy consumptions and some related variables in a certain building, for example. And here, the citizen can compare their energy consumptions with the average. So whether they are underperformed or overperformed. For example, in this case, so the citizen should happy because their energy consumption is lower than the average, for example. And also we can use the linked data approach for healthcare. This is our initiative in our startup, which is based in Indonesia, actually. So still in progress. This we use so-called or the concept is based on the patient-centric healthcare. So where we link the data about the patients. For example, here we have the data. This is based on the concept in Germany that we have the information about the patients from some sources, like from the insurance company, and then we have some clinical data from a hospital, for example, that is about the lung of this patient, this guy Max. And then we can conduct some kind of data analytics or machine learning to this is just a simplified example, for example, that we can detect disease from data collected in the hospital. And then the result of this machine learning is then integrated back to the knowledge graph, so that we establish connections, for example, that Max has lung and this lung has disease, for example. Before the conducting the machine learning algorithm, then we cannot we cannot say that this max has a disease. But after that, after doing the data analytics or machine learning, of course, with the help of the doctors, then we can establish so that this guy Max has disease in his lung. And the third project is about the manufacturing. So because of the introduction of renewable energy, we cannot plan how much energy will be generated, because it depends on the weather. So that's why the consequence is that the consumption side should be careful. So that means the consumption side should avoid the peak load. So that means we need to reduce peak load. So that the project is about how we can collect the data from the consumption side so that we can develop a production planning that can avoid planning and scheduling that can avoid the peak load here. So this is just simulations of using Raspberry Pi that is attached to simulators. This is a machine simulator that we can measure the energy consumptions and also can monitor the activity of the machines. This is further developed in the project called Delphin here. As usual, in Germany, we cooperate with between research and industry here. I don't want to go into details in this, but in principle, we also use the method of knowledge graph to integrate the data in the smart grid that connect the energy consumption side with the energy generation sides. So on the top of the knowledge graph, we perform some data analytics and machine learning, and also optimization and simulations. So the data sources are from different places, from different locations here. And we are starting now a project called Helena. It's about a framework of data-driven integrated smart energy system. So that means the surface energy service is then integrated with other services like water, waste service, and so on. And we also cooperate with different countries here, with Trinity College in Ireland, Exeter University in UK, and some research organizations in France, Italy, and Spain. So what is the implication for Indonesia? So of course, this Industry 4.0, I think we need to focus on the sectors that give wider impacts, especially for people living in the rural area. That means not only Industry 4.0, not only for the people living in the cities, but also in people from the rural area. So the second is to optimize what we have in Indonesia. So the key natural resource of Indonesia. So that means actually the Industry 4.0 technologies enable us not to exploit the natural resource. So that means by using ITs or these technologies, we can optimize the use of the natural resource. And the focus is the human skill. That means we need to upgrade the skills of the human, not to focus on the strengths like physical strengths or strengths like memorizations and so on, or monotony. And we need to optimize the cooperations or the ecosystem, which is based on the cooperation between people living in the rural area, startups, SMEs, governments, and researchers. And the focus is to bring Indonesia as leader, not just follower, not following the others in other countries. And now the question, which sectors that can make Indonesia to be leaders? So I would say that this 5 sectors would be the best, because we have rich of agriculture resources. We have fruits that, for example, in European country they don't have, and we are maritime countries, so a lot of aquaculture resources. We need to maximize it, to optimize it, not to over or exploit it. And also the mining, we have also rare earth sources, and renewable energy. Yeah, renewable energy. We have what do you call it? Thermal energy resources, wind, marine energy resources, and so on. And of course, healthcare, because the Industry 4.0 technology provide global access. As long as we have internet connections, we can do telemedicine, for example. It's open the opportunity for people who live in the islands to have healthcare through telemedicine, for example. So the focus should empower people from rural areas. Yeah. And some takeaways of this. This is my last slide. Takeaways from this today talk is this Industry 4.0 ecosystem consists of 4 pillars: yeah? Smart PPR, product, process, resource, and data-driven service. This is the core, the pillar, and the implementation sectors may vary from agriculture, aquaculture, mining, and so on. And Industry 4.0 enables global access to a local product. So that means also healthcare as a product can be accessible everywhere through telemedicine, for example. And linked data or knowledge graph, in this case, and data analytics play central roles in Industry 4.0 because the ecosystem of Industry 4.0 is about data exchange and data integrations, data linking, and providing value-added service based on the data. And the linked data or knowledge graph enable the shift of integration paradigm from data exchange to data linking. And the focus of Industry 4.0 in our country or Indonesia should be to optimize the value and efficiency of human and key natural resource, not overexploit them, not to just to have financial profits or more advanced technologies, but we need to optimize these human and key natural values, key natural resource values, and empowering all people, especially people from rural area. So is my presentation. Thank you for your attention. Please apologize if there is something that went wrong and so on. So please, Professor Santi. So
Okay,
if there are
thank you
questions,
very much,
then yeah.
Professor Hendro, for your excellent presentation. Maybe we didn't have 20 minutes, only 15 minutes for question and answer. I would like to read some question. Okay, first, this is the question from Dr. Erwin Widodo from MTL Research Center ITS. The question is about the main challenge in data management and data analytics is how to collect and organize this data. Could you give tips and tricks how to do such tasks effectively and efficiently? So the main question is how to collect and organize the data effectively and efficiently.
Yes, thank you for the question from Dr. Erwin. So I think it's a very relevant questions. So the problem of data collection is still a huge problem also in Germany. So because like if the data or if the system is owned by one organization, like a company, for example, usually it's no problem. For example, Germany is quite very good in developing artificial intelligence in the context of industry, but quite poor in implementing AI in daily life because of the problem in the data collection, because the people are reluctant to share their data. This is actually the huge problem, because without data, AI that won't work. So like in China, maybe the government forced the people to share their data, like having like resilience camera and so on. And in US, the companies get the data that we don't realize it, for example, from Facebook, Twitter, and so on. So to be able to activate people in order to participate in the data collection, we need first the technologies. The second is the regulation. The regulation is important. We need to have a regulation that makes sure that the data is protected. Protected, not the data that's shared by the people is protected, and then the people feel safe to share the data. And the technology, for example, we can anonymize, or have technology that anonymize the data, so that we hide the identity of the people who are behind the data, who own the data. So I think there should be two approaches: regulations and technological. Yeah, that's my answers.
Okay. So the next question is this from this one. This is from practitioner as manufacturer professional from Ari Haryanto, I think. What is the best way for manufacturer to transfer from current condition to industry 4.0 era? So what is the best way for manufacturer to transfer from current condition to industry 4.0? Yeah.
Okay. Yes. So to transfer, this required a long process. So to transform into, like, if I consider the definition of smart PPR as a pillar of Industry 4.0, to achieve all of this PPR, it needs time. Even in Germany, there are no companies or manufacturing company who be able to implement all of these three pillars. So in the on the highest level, so they partially implement it. So the way to move towards this smart PPR first is to have a strategy on the management level. So that means the management level should have a will to invest on the technologies, invest on the human resource to prepare towards Industry 4.0. Like to buy, to invest on the internet connection, fast internet connection, for example, on the installing sensors, for example. It should be from the management side. Second, the human resource need to be ready. So that means they should aware that their work will change. Yeah, not the process will change. Yeah. And the IT capabilities of the company also need to be upgraded. So, for example, now the trend is in every big company there is a CIO, Chief Information Officer, which is like coordinate the IT activities in the company, and we need then the IT need to have central coordination. Even Germany, there is a Ministry of Digitalizations who coordinate the adoption of digital technologies in the country. So that means this kind of centralized or central department that coordinates the IT is quite important. and then go towards, and then after that we move towards these 4 P's. This PPR, smart PPR, and the company need to think how the manufacturing company to provide this data-driven service along with the product. So that should be the vision in the future, that the company need to provide data-driven service along with the product. So I think this my answer for the manufacturing companies.
Okay. I hope it's enough for Mr. Ari Heriawan. Now we move to the next question. We have 2 questions more. The first question is from Ani Mariani, Industrial and System Engineering Department ITS. It is interesting that Indonesia need to be focused on human skill, not human strength. Could you please describe more detail what kind of human skill that's suitable with Indonesian people characteristic, culture, and education in order to gaining better with Industry 4.0? It's about human, I think. And maybe one more. This is from Aswin Aryawan from Bachelor Degree of Industrial Engineering Undip. This is a little bit theory. There are some terms that seem similar to me. Could you explain the differences between data science, data analytics, artificial intelligence, and machine learning? So you can answer from the first question from Ani Mariani.
Yes. Yes. Human skill means that it's a skill that we can acquire from intensive education and training. And human strength is something that through some practice which is quite monotony, and monotone practice, we can achieve like memorizations, physical strength, for example. These are human strength, and human skill like problem solving, creative thinking, teamwork, and so on. Yeah, I think the character of Indonesian people is open. This is actually the a good characteristic for Industry 4.0, good character for Industry 4.0, because one of the core or the prerequisite for Industry 4.0 to be able to collaborate with everyone, open-minded and so on. I think if we as Indonesian, we keep this open-mindedness or open friendliness with people, so I think it's a good point to compete or in Industry 4.0. And other thing is maybe this problem solving is something that we need to improve, that we need to, in order to have good problem solving skill, we need to be able to structure the problems. So that means we need to identify the problems, what in our environment, and to structure it and associate it with other problems or other solutions, and then also structure the solutions and develop the planning for the problem solving. So what I realized from my Indonesian students comparing to like German students, for example, I think we are quite behind in this problem solving skills, because I think we need the education systems, especially on the elementary and middle level. Yeah, we need to have more curriculum which promote the reading skills of the students, so to be able to read, for example, and then not just to read and then present, but to restructure what they read into some kind of mind structure, and then to present it or formulate it in the kind of way which is can be accepted by other people. So that's one thing. And then also, of course, IT skills. IT skill is at least to be able to use the tools, to use the, for example, data analytics tools is also important for the Industry 4.0. And about the second questions, what is the difference between machine learning and artificial intelligence?
Yes.
Yes. So this is actually the term of artificial intelligence is more general. So it's about the disciplines or the subfield in computer science that simulate the human or intelligent human behavior. So it's including this three behavior: learning, data processing, and interactions. And machine learning is part of artificial intelligence, which deal with how the machines can extract knowledge, extract patterns, extract relationships on the data. So that means how the machines or how the computer learn from the data in order to produce some kind of knowledge or pattern that will help the people or human to perform decision making. So machine learning is subset of artificial intelligence, and the data science is a science to deal with analyzing the data, extracting the pattern of the data. It can use simple statistical analysis, or it can use machine learning. So that means machine learning can use to perform to data science, and data analytics is actually also subsets of data science which deal with these four aspects. Data science also includes like how you understand the data in the context of the applications. So that means, for example, data science that applied in smart cities. That means you need to know the context of application of data in the smart cities and how the result of data analytics can be used in smart city, for example. But data analytics only focus on this four aspect. Yeah.
Thank you very much, Professor Hendro. I believe we have many more questions, but time is very limited. Thank you again for your presentation. It's very excellent. So I will, this session will be end, but the participant can give appreciation to Professor Hendro by pressing the reaction button. You can give the Professor Hendro your thumb. Okay. Thank you very much again, and see you next time. Assalamualaikum warahmatullahi wabarakatuh. I give back the times to the moderator, to the master of ceremony. Thank you very much.
Thank you to Professor Dr. Hendro Wicaksono and Professor Dr. Ari Susanti. That was a very great topic. Now we are going to take a 5-minute break. as we're going to start again. Our last plenary session for the conference will be presented by Associate Professor Ferry G. from Edith Cowan University, who will speak under the theme Supply Chain Big Data, an opportunity for future research.
We would also like to invite Dr. Engineer Erwin Widodo, the Head of Manufacturing, Transportation, and Logistics of Institut Teknologi Sepuluh Nopember Research Center, to become the moderator in this session. To Dr. Engineer Erwin Widodo, the time is yours.
Thank you very much for the Master of Ceremony, Mr. Furkon and Ms. Indira. Good morning, ladies and gentlemen. On this occasion, we have been coming to the plenary session number 5. As written in our conference schedule, the title of this plenary session 5 is about supply chain big data. And we are welcoming Associate Professor Ferry G, PhD from Edith Cowan University. As the short curriculum vitae, or the resume, I would like to say some points. The first is Associate Professor G got his doctoral degree in the year of 2008 from the University of Sydney. And as his employment history, he started his lecturing experience in RMIT University College of Business. And now he is an associate professor as well as deputy director in Edith Cowan University, SPL. His main research interests are about business analytics, project management, supply chain management, logistics, and some areas around that. He got a lot of research grants starting from the year of 2000, at the beginning of 2000, and several awards and recognition, as well as experience to do some invited speaker activity or keynote speaker in some conferences, public lecture, or research workshops. He is also published more than 50 articles in well-known international journals, as well as some conferences. And due to our time limitation, I would like to remind Professor Ferry G, you have around 40 minutes to deliver your lecture or your speech here, and then will be followed by 20 minutes of question and answer. And for those all participants who wish to give any comments or any question, please key in or type your question into the SharePoint provided in the links in our chatting feature in our Zoom meeting or Zoom application. And time and place is yours, Professor G, please.
Okay. Good morning, good afternoon, ladies and gentlemen. First of all, I would like to say thank you very much indeed to ITS and Diponegoro Universities. Just would like to thank you to rectors and deans and head of department, as well as the speakers, as well as the participants. Also would like to thank you to committee to invite me to share about the supply chain big data analytics about today's conference. So can I please get some host to share, to let me to share the screen, please? Thank you. Before we start, for my slide presentation, just want to double check so everybody can get my slide for today's conference.
Yes, I can see your slide.
Thank you very
clearly.
much.
Yes.
Yeah. So right. So thank you very much, moderator. Dr. Eru Erwin Widodo. Just would like to share about supply chain big data analytics future research opportunities. So my name is Ferry J. I'm currently associate professor in supply chain and logistic management. If you really want to connect, I'm in LinkedIn, as well as you'll be able to contact me through email f.jie@ecu.edu.au. If you really want to have a good conversation for collaboration, doing research publication together, this is my WhatsApp number, +61 414 968 978. Just would like to, as moderator has introduced me, so my research area is pretty much in supply chain and logistic management. My education background was industrial engineering, and my research project currently is pretty much multidiscipline. So currently I'm a deputy director for Center for Innovative Practice. As you know, Edith Cowan University is located at Western Australia. So it's about 3.5 hours by flight from Bali, Denpasar, to go to Western Australia, to go to Perth. So we only have 1 hour difference between Jakarta and Perth at this moment. So so Edith Cowan University consists of 8 schools. So I'm in the School of Business and Law. So in my research center, I have more than 65 members, mostly from academic scholars in the area of the business innovation, operation management, supply chain, logistic, project management, information systems, and so on. I'm currently published more than 50 articles. So in the Q1 and Q2 in the top ranked journal, which is higher top tier journal. And then I received research grant is more than 1.6 million between 2010 and 2020. So talking about my research project, so since we have the COVID-19 situations, so the Western Australia, we have a state government, Western Australia, giving research grant, which is I received research grant recently with my colleague about business continuity and resilience, capacity building and upskilling post-COVID-19, funded by Department of Job, Tourism, Science and Innovations. The project is 12 months project. And the second project actually currently dealing with the a transport system investment risk, enhancing patronage prediction and adapting strategic asset management and appraisal process to account for emerging trends and uncertainty. So this is the project funded by iMove Australia, so still in progress at this moment. And then the third project is dealing with the blockchain, which is the, Professor Wicaksono mentioned about the Industry 4. One particular area about the financial planning and, in the services supply chain, a blockchain project in Australia. And the fourth project actually with the City of Council, doing project about waste project with the City of Joondalup. And then project with the logistic transport with Fremantle Port, already completed, last year before COVID-19. That's the second largest project actually I've been doing for the last 24 months. And I think Professor Wicaksono mentioned about smart city projects. So in 2018 and 2019, the project actually what I got with the University of Western Australia, Planning and Transport Research Centre, and Department of Transport and Department of Industry, Science and Energy Resources. The project was about the smart city project in Waneru planning support system. Is funded by City Waneru. So pretty much is similar what Professor Wicaksono explained in terms of implementing of the big data and analytics in the area of the smart city, dealing with the rail smart in the City Waneru. And the next project actually currently just completed with the rail project, which is the Australia Centre for Rail Innovation, already completed and has been published in the international journal. Logistic management, a cross-docking has been published. The project already completed. A review model applications with my colleague as part of the internal funding. The project actually already completed with the University Muhammadiyah Malang, which is Halal Meat and Halal Meat Logistic Performance. It's funded by Ministry of Research, Technology, Higher Education of the Republic of Indonesia. That's pretty much about the halal logistics projects. Then the projects, talking about the ontology-driven business intelligence frameworks already complete and has been published in a top-tier journal. So before I start for this, I just have a video presentations, ladies and gentlemen. Hopefully, it's worked with the video presentation talking about the project what I just did with the toll and COVID-19 project. Maybe I would like to share video. Just want to make sure it works. And share computer sounds. I'll just go back this slide again. Okay, so I just got the video presentations. Couple video. I just would like to start with the project with the Department of Health in COVID-19, dealing with the pandemics in the supply chain context, dealing with the agriculture, agribusiness, food, during COVID-19. So it's about 1 minute, 32-second video presentations. So as you can see, during COVID-19, actually, the supply chain and logistic industry actually is the main role for particular, during pandemic. You can see everything, digitalization, digital transformation, dealing with the e-commerce, e-business, supply chain, information system. As you can see, agriculture, food, FMCG are very busy during COVID-19, even for the new norm. Post-COVID-19. So if you can see the FAO and the World Health Organization as well as United Nations Organization, pretty much actually to encourage actually particular countries to look at about the supply chain, food safety, safety and then healthy environment in the workplace. As you can see the video showing during pandemic, everything's product actually empty shelf. The product actually run out because during pandemic, this is the Food and Agriculture Organization of the United Nations. So I just would like to share one more video about the big data. That video actually talking about
very difficult crisis because of the coronavirus. This is no longer a regional issue. It is a global problem.
Okay, the video presentation now talking about DHL data analytics. So the project actually with the third-party logistic provider. As you know, the third-party logistic provider, what we call 3PL. DHL actually implementing data analytics, supply chain data analytics very well, as you can see in the video presentation, about 2 minutes 44 seconds.
Data is important to our customer when it has a story behind it.
DHL data analytics helps me a lot to understand a specific level of risk for a particular lane. As an example, if we go to a very hot environment, especially for our own products that we have to keep the temperature at 2 to 8 with very limited stability data, it's going to be extremely useful for us to understand the risk before we even ship the product.
You know, we're using our own internal data to understand certain patterns that you might not see if you just look at a handful of shipments. But if you look at the history of shipments over time, you might detect when a certain weather condition at a certain point in time kind of comes together, then we see temperature excursions.
We've established a tool which allows our customers to quantify their risk in a way that we've never been able to do before.
So the primary source of our data is our LifeTrack system and the smart sensor data loggers that we place on all our shipments. We're able to bring other data into our system as well. We have a tool that we call Connection. We're able to connect other data sources. We can bring flight data in, we can bring weather data in.
The data needs to be connected, and that's what our vision is. We want to have the data platform, the connector, that we can actually combine our customers' data with our data and make a whole lot more sense out of it.
So this is something like Professor Wicaksono mentioned about linking data. So what DHL actually implementing, actually linking data. If you look at you know, furthermore to listen for DHL data analytics.
We complement each other because we give our knowledge further to our suppliers. I'm talking about the airlines, I'm talking about the steamship companies, I'm talking about companies who are responsible for packaging and what have you. So in the whole chain, I think the life science industry benefit from our knowledge, and we can complement each other when it comes to the shipping world.
Over the course of the next 5 years, those companies that adopt data analytics strategies will be ultra competitive in the market, and those that don't will deem themselves irrelevant or extinct.
It is ultimately for the patient safety. We want to make sure that this data that we collect and analyze has become very instrumental when it comes to transporting the cargo, to make sure we deliver the healthcare products to every single patient around the world with product integrity.
Thank you very much. So just wanted to share, go back to my slides again. All right, so if you look at the DHL data analytics, so you know, with the Industry 4.0, I think Professor Wicaksono actually mentions a lot actually in terms of evolution Industry 4.0. So it depends on the time, because I would like to share with you as well in terms of how a logistics organization enables big data and analytics to transform supply chain management. So if we have a you know, time, I go back to this video presentation again if we have more time about that. Okay, so talking about the supply chain. So before I'm talking about supply chain big data analytics. So everybody knows in this conference about supply chain. So as you know, supply chain, actually, we have a numerous definition of supply chains. I think more than 22 definitions. So, you know, from 1990s and up to now, we have a lot definition about supply chain. So pretty much supply chain, if you look at the flow of product and information, including services, from raw materials, components, work in progress materials, you know, final products, you know, to the focal firm, what we call the manufacturing industry, and you got logistic providers, you got the distribution, transport companies, you got wholesalers, and you got retailers, right? So that supply chain logistic, then we connected with the transportation, you got storage, integrated through information planning, integrations activities. So if you look at, for instance, like Australia at this moment, so we do have the two largest supermarkets, what we call here Coles and Woolworths. You know, pretty much vertical integrated supply chain. So they're implementing very well in terms of supply chain big data analytics. You know, from the customer demand data, you know, and supplier data, product data specification. You know, doing very well in terms of scanning technology. You know. Tracking, traceability, and so forth. Okay, so this is the definition of supply chain. So I don't want to explain more details about what is supply chain management. So pretty much, if you look at supply chain from the Council of Supply Chain Management Professional. So currently, actually, I'm a steering committee for the Supply Chains Logistics Association in Australia, as well as the Charter Institute Logistic Transport. So we have a 100 years. When I was in Manchester, that particular we got the big congress in the SILT, Charter Institute Logistic Transport. You know, back then in Manchester University. So the particular Charter Institute Logistic Transport actually implement quite a lot actually in the area of Industry 4.0, Supply Chain 4.0, Transport Logistics Information System, Transport Management System, Logistic Information System, including Supply Chain Big Data Analytics itself. So what is supply chain management? The planning and management, if you look at the planning and management of our activities involving in sourcing, procurement, conversion, and all our logistic management activities. Also includes coordination with channel partners, which can be suppliers and intermediaries, third-party service providers, and customers. So this is from CSCM professional. So with the other definitions pretty much similar, like from Institute for Supply Management in Houston, is that the design management of seamless value-added processes across organization boundaries to meet the real needs of the final consumers. So in the last 5 years, I look at the cycle in terms of my research output for my publications. So published in more in supply chain empirical, supply chain data, exploratory study, supply chain in different contexts, in pretty much in the beef, red meat, halal supply chain, halal food from my with working with my PhD student. Two of them they graduated now. They you know, teaching at UITM in Malaysia. One Hafiz working at UITM. So we publish quite a lot in the halal food supply chain in the top tier journal. One of the journal is the journal Islamic Marketing, and as well as the International Journal Logistic Management. So it's a particular project actually publishing in the Journal Supply Chain Management, International Journal Logistic Management with my PhD student. It's now Indonesia PhD student actually publishing together with the supply chain competency published in a Q1 in a journal, International Journal Logistic Management, about the competency, supply chain competency in operation managers in the third-party logistic providers. So if you look at the third definition from Association for Operation Management, you know, in the angle of the industrial engineering, system engineering, we do have operation management, supply chain management domain. So the Association of Operation Management defines supply chain is the design, this planning, execution, implementation, control, as well as the monitoring supply chain activities. So as you know, supply chain activities, you know, including procurement, including production, including transportation, including that inventory demand itself, and so forth. What is the purpose of all those activities? To create net value, building competitive infrastructure, leveraging worldwide logistics synchronized supply with demand, and measuring performance globally. So if you academic scholar, so I strongly encourage you to watch so many top tier journal introduce special issues if you want to publish in top tier journals. So there's so many papers in the supply chain during COVID-19, supply chain big data analytics, post COVID-19. So there's a special issue under International Journal Logistic Management, IJOPM, or one under Supply Chain Management and International Journal. Those journals are Q1, which is a top tier journal. So now, if you look at the this slide talking about the in the long term combined connected technology will unlock new mechanism for creating and distributing value. So Professor Wicaksono explained a lot in terms of artificial intelligence and machine learning. I don't want to explain again about this because what you're looking at this framework, we are in the new era, which is Industry 4.0. So if you look at the COVID-19 pandemic start in January, back in China situation, now in US, all countries around the world. So talking about supply chain digitalized transformation. So if you look at creating value from converging technologies, so everybody look at the, like, say, for example, Internet of Things, the advanced analytics, this is coming for in the supply chain big data analytics, the, AR, VR, and you got robotics there, you got 3D printing. This is something what we can look at, in terms of the Industry 4.0 tools, right? Now, if you look at on the left-hand side, the value dimensions in the what we call different stakeholders. So within supply chain itself, we do have different stakeholders. So what are they in the stakeholder? We got supplier, we got factories, we got government. In individual company, for instance, you can see the society, you can see the industry, different sector, mining, agriculture, retailers, service industry, and so forth. And you got organization and factory. Right, so you got the value dimension, you got value mechanism. Now, people a lot talking about new skills. So what I'm working very closely with the Western Australia government, talking about upskilling. So in the post-COVID-19 at this moment, in what we talk about new norm, pretty much actually organization need to think about resilience, supply chain recovery, and make sure the businesses really survive post COVID-19. So if you look at the during pandemic, it actually hit a lot of industry, pretty much tourism, hospitality, aircraft industry, and a lot of fashion companies, a lot of tourist destination, a lot of since a lot countries actually shut the international border. This is pretty much the global economy, we got recession. So if you look at the new skills in particular Industry 4.0, this is very important. This is our biggest homework for education sector. How do we make sure our graduates, our students, pretty much to understand, to be capable, in the evolution 4.0, for instance. So we need to revisit the curriculum, for industrial engineering, management, any business school. We need to make sure the graduates really capable with the skills, and it's what we call in ECU, Ethical University, work ready. So we would like to make sure the students and graduates and really capable to work in an industry. So this is this is our biggest homework. Make sure we need to update the curriculum to make sure the students and graduates actually to learn about new skill capabilities in the area of the Industry 4.0. Now, the technological augmented operators, and this is particular, we need to look at the accelerating sustainable production. The Professor Hendro just sort of mentioned about smart processes. That's pretty much about, he mentioned quite a lot in the previous presentation. And a smart structure there, and a smart innovation, digital orchestration of the supply chain. That's coming to the smart supply chain and personalization product here, and the new business model, right? And the digital experiences. So COVID-19 really introducing a lot in the digital transformation, any businesses. So like my university next week, so thank God, because next next week all my students going back to campus live. So no more online. So even though I got my student from Sri Lanka, so I still connect with the online with my student from offshore students. So I'm using blended learning at this moment. Still a virtual class, plus as well as a face-to-face. So I'm using the two devices. So one with my laptop, actually still connecting live streaming, connect with the offshore student, overseas student. They not be able to come physically to Australia because our international borders still closed. Now, that particular, I'm still doing face-to-face as well as live streaming. So good thing actually in Western Australia, we don't have any cases. So the COVID-19 actually no problem. So far so good in Western Australia. So everything back to normal. So people can say that new normal. Unfortunately in Melbourne, so a lot of people said second wave, because like last night still got problem with 484 cases in the last 24 hours in Melbourne and Victoria. So Australia has it's a state country. So we do have Victoria, New South Wales, and now myself is located in Western Australia. Okay. So if you look at challenges, this is very good if you really want to do research in the area of the supply chain 4.0, supply chain in the big data analytics. The challenges, of course, about technological readiness. Whether or not the industry or organization, whether they, technological readiness is very important to look at. And security, in ECU, we do have a cybersecurity, institute, which is the research center dealing with the cybersecurity standards. Talking about the barcoding, global standard GS1 in Australia, working very closely with Coles supermarket to introduce the barcoding, standards. This is creating about big data itself for the stock or inventory or demand data and so forth. And interoperability, data management. Hendro mentioned about this data management. Change management itself is very important research, in particular supply chain empirical or supply chain exploratory study in the change management, as well as the capability, competency management, and culture, right? Just would like to see whether, so I just show actually, but moderator, you'll be able to remind me, isn't it, if I still have plenty time? Yes? Anyway, okay, just keep going. Now, talking about culture, one particular good questions. Yeah, thank you, Pak Erwin. About culture, pretty much is very important. So, as you know, industrial engineering, system engineering is a multidiscipline researcher. If you talk about culture itself, supply chain culture dimension, culture in terms of the organization culture itself, to adopt in the industry 4.0 tools or a supply chain big data analytic conceptualize, this is something we need to look at what theoreticals in the area of the organization culture itself, right? So the capability development, culture, and supply chain competency, big data analytic is a challenges as well in the area of the supply chain industry 4.0. Now, this is, I work with my research assistant, which is the postdoc, talking about supply chain management, big data analytics since 2018. The project, and now the paper is still under review. under Journal of the Transport Review. The purpose is of this project is to conduct a systematic review of the supply chain big data analytic literature in the Principal Logistics Supply Chain Management Journal across a 5-year time frame. The analysis will identify the key themes of previous studies and provide research agenda to guide researchers going forward. So if you look at this evaluation big data analytics, so what we call BDA, right? BDA is big data analytics. So if you look at big data, it's exactly the same time when the supply chain was born. So supply chain was born in 1970, say for example. If you look at, you know, it start already big data, but people did not realize that big data is a statistical techniques in the 1970s. And the 1980s start already data mining, right? And then 1990 is start with the BI. BI is a business intelligence, right? 1.0. The key enablers is EIS, which is what we call Enterprise Information System. So if you look at 1990s, the Bachelor Information System Studies is pretty much is there, is 1990s, right? And then it's a business analytics, which is what we call BI 2.0. The key enables internet. So that's why you got web-based technology, 2000, social media coming, Facebook and so forth, Twitter, blah, 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 and a lot there, right? So if you look at the complexity of data itself, so the more you look at the business analytic 2.0, big data analytic, which is 2010 beyond, or BI 3.0, is pretty much high complex itself. We're talking about data complexity, right? So the key enablers is a radio frequency identification. People know that. In supply chain scholar, we know that. So the RFID, any retail giant supermarket like Walmart, Tesco, Kohl's, Woolworth, they use very good in terms of RFID, radio frequency identification, sensor-based devices, Internet of Things, and so forth, right? So this is pretty much about the evolution of big data analytics, what we call BDA, right? And then what is the benefit of supply chain big data analytics, right? According to the literature review, if the supply chain big data analytics is to provide the tools, right, to support decision making. So this is about decision making in global, volatile, dynamic failure networks. So if you are practitioners, so you need to know, say for example, the supply chain director, right? Before doing decision making, the big data analytic is pretty much to provide tools, right? To support, to help you with the decision making in terms of inventory, in terms of demand forecasting, in terms of facility layout, in terms of the lean approach you want to implement that, in particular volatile or the dynamic failure networks. And of course, big data analytics to improve demand forecasts. A lot of papers publication in the supply chain big data to improve demand forecasting. So unfortunately, something new about demand forecasting really, because a lot of papers already published in the 2015, 2014, big data analytics improve demand forecast. Of course, to reduce inventory, particularly reduce safety stock, and improve the management of supplier performance. This is quite a new in the area of supplier performance. You know that in the supply chain, echelon, end-to-end supply chain, you got upstream, you got downstream. Talking about upstream, you look at supplier, right? You look at vendors, and you got procurement activities there. So in terms of to measure your supplier performance, so we still can use the big data analytics. So if you look at supermarket like Kohl's, Woolworths, Kohl's, we do have a more than 750 store in the country, right? in New South Wales, Victoria, Melbourne, and Perth, Western Australia, ACT, Canberra, and so forth. Woolworths, the same thing. Second, we do have two largest supermarkets, Coles and Woolworths, more than 700 stores. So they have a lot of suppliers, right? So many stock keeping units. So the supplier provide products, grocery chains, any frozen food, dairy products, actually to retail supermarkets. So, you're dealing with the big data. What types of big data from suppliers? It's pretty much stock keeping units, timeliness, inventory, right? A demand from downstream, back to the upstream. So you need to monitor, and then you need to share the information or data that we can measure that's supply chain or supply performance. Okay. A Safer research study indicated a big data application in various sectors. I think Professor Hendrich also mentioned there it's about agriculture, because my PhD about supply chain analysis in Australia beef industry. So pretty much, my thesis I mentioned about the big data, developing the supply chain of beef industry for Australia from cattle producers back, pretty much from farm to plate, right? Pretty much from cattle producer until you eat rendang, right? So this is what we call the beef supply chain, right? So agriculture, that's we need to look at the supply chain big data analytics. You can see how complex supply chain, upstream to downstream. And also we consider supply chain sustainability, which is the reverse logistics product return, right? Or remanufacture, recycle, reuse. So if you look at the forward and then backward, the supply chain, the upstream, downstream, downstream, back to upstream. So if you look at this so complex, and the data you deal with, the big data, then we need to have the analytics approach. In the purpose, actually to make sure for to achieve demand fulfillment, to support decision making, as well as to reduce inventory, and in the end, we would like to improve the supply chain performance measure. So again, the big data BDA actually, can be implemented to any sector, including financial services, financial institution, banking, insurance, hospital, marketing, insurance industry, logistics, and even manufacturing or mining sector as well. Now, talking about the systematic literature review to investigate the application of big data analytics in supply chain. So I think you can see if you publish in the top tier journal Q1 or Q2, or hopefully you're not publishing Q4, you can try to look at the literature review. You can see Barbosa mentioned about the big data, BDA. Technique usually use the predictive, prescriptive approaches rather than descriptive approach. I think the Professor Hendro mentioned, that you got 4 in terms of big data analytics. Yeah. So talking about predicted, prescriptive, descriptive. So Barbosa in 2018 published in Top Tier Journal, he mentioned about the looking at predictive and prescriptive approach compared to the rather than descriptive approach, right? Darby actually in 2019 actually mentioned about the effectiveness of big data and predictive analysis on 2 aspects of sustainability and supply chain sustainability context, right? Including environmental performance and social aspect, right? This is interesting because if you really want to publish, you're doing good. You got a paper published in a journal, Cleaner Production, in its very high impact factor journal. They really like the paper about supply chain sustainability. They really like talking about supply chain environmental performance, right? So Darby actually looking at the big data implementation in the supply chain sustainability, environmental performance, and social aspect, including triple bottom line. Now, the Gupta in 2019. So this is conceptual paper. Gupta actually looking at the comprehensive literature review, the 28 journal article to investigate the impact of the using BDA technique and on the humanitarian. So we do have an international journal humanitarian supply chain logistic management, which is the Scopus. The humanitarian supply chain, if you have a project or paper talking about humanitarian, natural disaster, COVID-19, dealing with the humanitarian context in the supply chain, this journal really like it, right? So Gupta looking at 28 journal article BDA techniques in the area of humanitarian supply chain, resilient in the natural disaster or in the COVID-19 context, for instance, right? Now, talking about theoretical underpinning, so I really want to share with you some particular journal, if you really want to publish papers in a Q1, Q2, if you look at, they really look at what theoretical underpinnings, when you do your study, when you're doing your research. So theories in the area surrounding a big data analytics. So you can see complexity theory because you can look at supply chain, it's so complex, right? So if you look at the first tier in the upstream in hotel industry, so you can see you got food services. If you look at hotel supply chain, the second tier, you can have a mattress company. In the third tier in the supply chain, hotel industry, you might have contractors, say for example, for the building itself. Now for the downstream hotel supply chain, I'm talking about service supply chain now, of a structure. In the hotel supply chain structure for the first year downstream, you can see is a brand hotel. So that's why you got Santika, say for example, you got Novotel, right? You got Ibis, Grand Mercure. So you got the first tier downstream supply chains in hotel supply chain. So, and then the second tier, which is the final consumer. So who are your customer, which is the individual customer or business customers, corporate customer, business or leisure travelers, something like that. So this is talking about the complexity theory in the area of supply chain big data analytics. And the second theory you can introduce, I would like to say that the transaction cost economics. So if you do more in the supply chain costing, total cost ownership study, supply chain costing analysis, you're dealing with the transaction costs. Transaction cost economic is important, in your study, in the particular when you publish in top tier journal. Now, resource depends theory. So this is pretty much actually looking new for in the area of the supply chain, the resource dependent theory in the area of BDA, right? And then resource-based view, very common. If you learn about strategic management, you know that fundamental, you learn about resource-based view. Social network, right? So I got my colleague actually, we about to submit the paper into the Q1 journal, International Journal of the Physical Distribution Logistic Management, what we call IJPDLM. Talking about supply chain social media. So the big data is social media, Twitter, Instagram, Facebook. Now my paper talking about the COVID-19. So what happened in Australia when the COVID-19 start lockdown in March, in the middle of March, start in February, the consumer know what's going on, the pandemic or COVID-19 pandemic. If you look at start in the curve in the middle of February or the third week of February until the first week of April, the consumer panicking buying. They go into supermarket to buy hand sanitizer, masks, rice, pasta, toilet rolls, tissue boxes. And then what happened that my project actually now we use the Leximensa software to pull out the data from the social media, Twitter, and then come up with the positive sentiment and negative sentiment. And then that particular Leximensa can, I'm still about to finalize the paper and I'm about to submit the paper. This is what we talk about social media. supply chain big data to influence actually decision, for the retail supermarket, what's going on. Because when you look at after April during pandemic, consumer panic buying, they look at, if you look at the supermarket, it's pretty much empty shelf, right? It's run out because customer actually want to buy as much as they can because maybe customer thinking it's going to be locked down. They cannot go out because of 14 days, and they really scared, and then they just pretty much they want to buy as much as they can, right? Now, what happened is the supermarket is really, really shocking when they look at what's going on here. So this is about supply chain disruption. If you look at the supply chain retailers and look at what's going on, it's very important to look at supply chain collaboration, and you can look at say for instance, your suppliers, whether your suppliers, the factory is okay, the workers okay, not affected by the COVID-19 positive, whatever, the factory is still open, and then they can expand more production process to fulfill demand in the supermarket. Because if you look at the empty shelf today, and then if you look at lead time, the lead time is takes longer, and then basically, and you cannot sell anything because it's product empty in the supermarket. So the supply chain collaboration very important. You need to work collaboration closely with your suppliers. Yes, your supplier can produce, can provide the demand fulfillment strategy and make sure, and also you need to work with the transport logistic providers as well, because this is what we talk about transport, to distribute the product actually from Eastern Coast back to the Western Australia. You need to look at the transport, routing as well in terms of the delivery time, and make sure the product is not, the product is in the market. Now, pretty much, if you look at the measuring the hand sanitizer in the supermarket in Australia, unfortunately, it takes about 5 weeks. When the product is empty, and week 5, and then more hand sanitizer there in the supermarket. So it takes 5 weeks, right? When the product empty until this product's there, right? So the same thing with the other product, like, any food manufacturer, FMCG, food manufactured consumer goods. So it's quite quick, pretty much between 2 and 3 weeks, right? So this is pretty much about resource-based view, social network theory, sorry. You look at the network theory in the area of the supply chain big data, BDA. Institution theory.
Professor G, because
yes?
of time limitation, could you make your presentation faster?
Yes, sure. Okay. Maybe, well, I still got 7 slides, so hopefully I can cover. Thank you. So the stakeholder theory, so everybody knows stakeholder theory, right? So you can see the suppliers, or you can see manufacturer, or you can see transport logistic providers, for example. This is stakeholder theory. So mostly my PhD student, they really like stakeholder theory. I don't know why. So my PhD student completed back then when I was from RMIT, the student used a stakeholder theory about halal beef supply chain. Now he's now in the UITM. We published a good paper in the journal Islamic Marketing. Now, ecological modernization theory, right? So and then what we're going to do for the next the literature talking about the techniques, right? The multi-objective optimization model for the green supply chain. So green supply chain is not new, unfortunately. So supply chain sustainability, yes, pretty much the green supply chain, the green supply chain, a lot of paper already published many years, actually since 2012, right? So if you look at the green supply chain, so Zhao actually in 2017 looking at the 3 different scenario, optimizing pretty much inherent risks associated with hazard material, carbon emission, and so forth. The problem challenges arising due to big data in the context of environmental performance, along with summarizing latest development in environmental management based on big data technology. Right, so this is, I just want to have it very quickly. A lot of literature, I just screened all the top tier journal in the area of the BDA, big data analytics, in different contexts, different country. India, China, UK, USA, Asia, Europe, Southeast Asia, what theories they is that using survey TOE, you know TOE, which is the Technology Organization Environment Framework. And then you can see the particular information processing theory, and pretty much they use a lot more survey and very less actually using case studies, right, or cross case studies. So this is the research objectives is investigation of BDA adoption determinants and the effect of the BDA on supply chain performance. Quite few papers there. Investigation of BDA adoption determinants is a lot actually since 2015. Now, just looking at the methodology data, so I just want to finishing off the methodology data, then giving you opportunity what the future research in terms of supply chain big data analytics. So this particularly useful for all academic scholar, practitioners, students or research student, PhD student, master business research student. If you want to do research study, you'll be able to look at what opportunity for research in the area of supply chain big data analytics. So in-depth evaluation of supply chain concept big data analytics is conducted using systematic literature review based on system approach. So this approach consists of sequential steps. So I use the collection using know, comprehend, application, analysis, synthesis, and evaluation is the key methods used to manage knowledge diversity for a specific academic inquiry and structuring field of research. The selected journal, so start from IGPR, production research, IGPE, production economics, PPC, production planning and control, supply chain management international journal. I think I remember OSCM, so editor with the Professor Nyoman. So that particular area quite a lot in the area of the supply chain domain, and international journal logistic IJLM, and there are a lot more journals articles. Now, between 50 and 60% of the research on big data application in supply chain were published after 2016. These publications have increasingly focused on big data application in pretty much predictive analysis rather than in other three types of data analysis. What are they? Descriptive analysis is very thin, very low level, right? It's pretty much descriptive. Diagnostic, right? A prescriptive analysis, this is the next level, right? So prescriptive analysis and predictive analysis, I think what you learn about simulation, this is what we call the OR techniques there, predictive analysis in the big data, right? So the research agenda come up with the literature review, come up with the 8 principles. So how ready organization for supply chain big data analytics in the area of transport logistics industry? How ready they are, right? So you can use the technology, organization, environmental theory, or you can use maybe, different theory, maybe you thought model, okay, technology acceptance model, maybe theory. Technical issues, right? The second research agenda, what technical issues surrounding in the big data itself, and then contextualize whether they implement it in the healthcare, smart cities, smart manufacturing. This is what we talk about contextualization. Methodological issue, you can look at, are you look at prescriptive? Are you look at predictive analysis? Whether or not you would like to do cross-case analysis, whether or not you would like to do empirical exploratory study, or which is the statistical analytical approach. Now, the measuring the benefit a business case for supply chain big data analytics, this is something is very good to look at. The benefit the business case, because the practitioner, particularly if you in university would like to engage within industry or the government people, you need to show the capability whether you be able to show how do you solve the problem using the big data analytics itself, and then you measure the benefit and each business case. This is something, since the industrial engineering, system engineering is a multidiscipline, you look at the organizational impact, right? you look at human resources skills, right? A lot of people talking about the manpower, actually workforce itself. So I think I mentioned before about upskilling and reskilling. The Australian government, Prime Minister Scott Morrison mentioned about the COVID-19 pandemic, actually, to introduce actually $2 billion about upskilling, reskilling all country in Australia, because this is the time talking about upskilling and reskilling. So you can look at the organizational impact and HR skill. And the other one is supply chain big data analytic and sustainability context. So you can see very good to look at the supply chain sustainability, supply chain big data analytic in terms of policy and regulation, right? Policy regulation is a good thing to be able, come up with the roundtable discussion with the government people, dealing with the decision making, dealing with the global trade operation, dealing with the free trade agreement, talking about the transport data, export data, for instance, connected with the policy regulations, say, for example. Now, what is the future research, the BDA itself? So I'm sorry due to the time, because this slide actually, usually it takes me nearly like half an hour to talk about each. Unfortunately, I cannot just explain. I just would like to show you BDA, what does it mean, Agile, the new norm for the post-COVID-19. So the business not only talking about lean thinking approach, not only about Lean, it means that lean is a Toyota production system introduced reducing waste, right? Inventory is a waste. Say, for example, cost reduction. And what is the agile? Agile is a lean and agility concept. The business need to be agile, need to be quick respond, dynamic changes, the post-COVID-19 for this situation. Of course, the business need to reduce costs, but need to be able to agile. So you need to look at big data analytics for a lean plus agility approach, okay, for the supply chain context. Supply chain big data for the supplier relationship. This is something, that's why we have a supplier relationship management. We got customer relationship management, which is CRM, SRM. Pretty much a big data analytics, actually, they created supplier relationship management as well as the CRM itself. And you can see the CPFR, you can see the vendors manage inventory VMI, CPFR, VMI, definitely they need to have a big data. Okay, without data, it's very difficult to reduce or to eliminate waste or to improve the supply chain itself. Now, network design, product design, in the industrial engineering particular discipline, we know that about the product life cycle or product design development. So big data analytics is also very useful for the product design development. Demand, right? Production planning, inventory control. So demand planning, demand forecasting, demand fulfillment strategy. Of course, for the demand stock keeping units, for demand product specification, characteristic, cluster for customers, domestic or global customers, all particular, we need to have the big data analytics in order to do demand planning. Procurement, which is the upstream supply chain context, the procurement management context. Customized production, cybersecurity in the supply chain domain. This is something industrial engineering come along to try to marry between the business particular oriented with the computer science discipline in relation to the cybersecurity, IoT, AI, machine learning in the area of the supply chain context. So this is the multidiscipline itself to look at the big data in the area of the supply chain cybersecurity. So I developed one new course in the Master Supply Chain Logistic Management at Edith Cowan. This is something I developed specialization under cybersecurity because the new course where I developed the Master Supply Chain pretty much actually to make sure the graduate to be able to face for Industry 4.0 era. So the curriculum need to be make sure the student be able to understand, particular for the skills capability in the era of the tools or industry 4.0 particular parameters. The inventory or stock management and logistics, the agile context, the lean thinking, sustainability, and so forth. Okay, so please give me 1 minute to finishing off. This is about supply chain, not dealing with the big data, right? So the previous slide is the supply chain big data. So this is about supply chain management, right? Supply chain management you can do on the left-hand side is pretty much about the business side. If you look at on the right-hand side here, is you can look at industrial engineering or system engineering can do that. So on the left hand side, business school or particular under management of technology or maybe in the engineering management be able to do that. Supply chain practices, performance, sustainability, quality, approach, dimension, the project itself, human resource, strategic supply chain. I know it's not very new, right? But still, again, you'll be able to do that as a future research. Cybersecurity, more on the right-hand side, more in the technological oriented, IoT, blockchain, and so forth. Okay. So thank you very much indeed for listening, ladies and gentlemen. Sorry, I cannot spend more about the future research for this. So I just would like to say thank you for listening. So if you have any question, feedback, or this is a good time for research collaboration. Since we are in the expert in the industrial engineering and system engineering, supply chain, big data, this is good time moment to work together, for this channel, for this conference. So once again, thank you for listening. Thank you, Pak Moderator, and thank you for the organized committee to invite me for this, to bring a presentation this afternoon. Thank you.
Okay, you're welcome, Professor Perigi. Through my WhatsApp number, I got a lot of appreciation about your presentation. We can feel your motivation, your sincerity to share your knowledge and experience, especially about supply chain and big data analytics. And when I check the SharePoint, we got 3 questions here. Fortunately, I can merge question number 2 and 3 become 1 because they are about similar. And for the first question, we got the question from Miss Putudana from ITS. And the question is about explanation in more detail about big data analytics with lean thinking. Even though you already explained in your slide, but Ms. Putudana want to know more about the relationship between these 2 concepts. Please.
Thank you very much. Very good questions. Right. So first of all, we need to understand about lean thinking approach, right? So there are 7 types of ways according to the lean principle, right? The supply chain lean thinking, actually, if you look at upstream to downstream supply chain, you can focus on even focal firm, which is the manufacturing industry. For the lean thinking, actually, it's a it's Japanese philosophy itself, the lean approach, right? So what is the relation lean? You know the reducing waste, right? One of the particular ways is inventory. Any organization in the supply chain industry, we do not want to have high inventory. For instance, like the furniture industry, or but maybe perishable products, for instance. So the relationship of the big data analytic itself, we're trying to make sure to reduce inventory, right? We just want to improve the demand forecast. So it's pretty much if you have the demand forecast accuracy is very good, right? Then you can control the inventory. You with me? So you got the control inventory. So when you reduce inventory through the big data analytics, because the big data, what does it mean big data? With the big data, you can have a stock keeping units, the inventory for each stock keeping units. You can see the tracking traceability, where the product coming from, which suppliers there, right? So you can track the big data analytic, you can do predictive analysis, right? Pretty much to improve the supply chain performance. You can use the particular big data analytic to reduce inventory and to improve the demand forecast, and therefore we can improve the supply chain performance itself. So it is very good concept, but when you do study, you need to look at contextualization though, right? Whether or not you were to introduce supply chain lean thinking approach for the big data analytic concept, and then you need to understand also what theoretical underpinning surrounding for whether you would like to use resource-based view, because the resource-based view can introduce or social network theory there, right? So there's so many clusters you need to consider to look at the relationship between lean thinking approach in the big data analytics, right? So big data, just remember, is a tool, right? It's particular, you need to look at the tools, the methodology, and analysis. And the lean actually is the deliverable, particular the supply chain outcome. Yes, the big data can help me, the scanning technology can help me, the sensor can help me with that, the GPS, all those types of the advanced technology to look at to manage the big data. Then you can look at the predictive prescriptive analytics there, and then you can look at the deliverable, whether the outcome, yes, the inventory reduced by 27%. Yes, the demand forecasting approach accuracy approaching 98%. Yes, the inventory service level is the 99%. You with me? So that particular big data analytics, you also can improve the can support the inventory manager for decision making, for the supply chain manager to determine which supplier they want to select, for instance. So yeah, thank you.
Okay, thank you very much for your explanation, Professor G. And let's go on to the next question, question number 2 and 3. These questions are from Mr. Imron Ghazali and Mr. Arif Rahman. And if I combine this or I compile these two questions into one question, maybe could you explain to us about how to manage data integration across supply chain entities, as well as how to manage the people behavior so that this BDA can be implemented successfully?
Very good question. Data integrations. So what we call about the integrated, you know, for data including data synchronization, right? So pretty much this is about the again the multidisciplinary research scholar need to do that, because data integration actually is very good for the system engineering can help, or the computer science people can help, the information system scholar can help. So a lot of research in the area of information sharing or information quality, the domain of supply chain. If you look at supply chain complexity upstream to downstream, and then if you look at reverse logistics, supply chain reverse logistics, right? Product can be recycled, remanufactured, right? So all the functionality of supply chain, right? So not only product movement, supply chain is not only product movement. Supply chain also information or data sharing. So all functionality echelon in supply chain, they need to update data actually. You know, there are different types of criteria in terms of the quality of data, right? So in order to manage data integrated itself, your end-to-end supply chain, you need to understand the supply chain structure, right? If you are supply chain people, if you don't know business process model, you don't understand who are your supplier, you don't understand supply chain structure, who are your upstream, who are your downstream, who are your transport logistic operators, who are you know, it's not good. You need to we need to understand the business process model, supply chain structure. Number two, In order to manage the data integrity itself, once we understand supply chain structure, then you need to look at, because supply chain is not product movement, it's not product flow, including information and data flow, right? Data sharing. That's why we need to improve, the quality of data. There are several criteria of the quality of data. It means data need to be up to date. It's not delay, right? And then data must be accurate, right? So in order to manage data need to be accurate, capturing data is very important. That's why we need to have information technology people to create particular. That's why we have a scanning technology. We do have RFID. If you look at DHL, right, in the video presentation, in the early my presentation, DHL did fantastic in terms of scanning, RFID, a sensor technology, with the, parcels, all the product before, they send it to the final consumers, right? So data need to be up to date. Data need to be real time. Data need to be accurate, right? So if the data not accurate, how do you look at the inventory in your database? And then in the shop, in the store, it says 2, right? But in your computer, maybe it look at 5. Why are we missing 3, right? Maybe your data in the inventory status is not accurate. You need to update the inventory, right? So physically, you got 2, but in the inventory status itself, it says 5. So it might be where the other 3, for instance, right? So it's very simple if you look at that, data. If you look at data information, right? So integrated, how do you manage that information sharing, information quality, that those particular ingredients to improve the supply chain performance, right? In terms of data integration. Now, number 3, right? It's very important to look at to have better understanding the tools and technology advancement. That's why in the early my presentation, I show you the framework, right? To talk about the IoT, we got AI and all those things. So as myself, because I'm teaching supply chain, because I'm teaching operation management, my background in industrial engineering. So when I look at the curriculum, so unfortunately, if you teach student, but unfortunately the technology very old, and then do you think that the industry really wants that, the graduate student? So this is something very important to look at, to have better understanding, know-how, and tools and technological advancement surrounding Industry 4.0 evolution, right? So when we have better understanding this, then you know how to use it, because sometimes you got the industry, you got brilliant technology, but you don't know how to do it. It's just useless, unfortunately. And of course, if you look at the contextualization, you can see the contextualization methodological issues, the way you do manage the data integration, you need to look at as well. Okay. Now, the last question talking about people behavior. This is something very, very good study I can mention, because maybe if you really want to do postdoc, or you got PhD, or you want to do PhD or doctor of philosophy, looks, because the people behavior, supply chain in particular psychological people behavior is a very, very important moment. Okay, especially if you look at before COVID-19, during COVID-19, and then post COVID-19, what do you think in terms of people behavior? Before COVID-19, so we do have face-to-face international conference, right? So now, when the COVID-19 introducing digital transformation, everything online, everything this, and now I need to work with the 4 devices now. I got my own laptop, I got my tablet, I got my Samsung, I got my Fujitsu tablet. Now, actually, all my children, everything digital transformation. So that's something actually talk about behavior changing, that paradigm actually from and then to, right? So this particular, we need to consider particular, maybe you can look at the cluster analysis, you can look at cross case study analysis. The people behavior is very important. That's something we look at: change management, cultures, right? Now, people behavior, it may lead to the skills. Now talking about upskilling, talking about reskilling, people in organization, right? So during like this particular lockdown, say for example, what you can do, you study, learn, webinar, actually what you do, right? So this is good time moment if you want to do upskilling yourself, the capability, knowledge, you know. And then what happened? Who knows, in 2021, actually, you know, COVID-19 is over, now back to normal, but you never upskilling yourself, and you're gonna be cannot compete with the global competitiveness in terms of the new skills, okay, knowledge. And then it's a shame when the people come to the workplace, they have no idea, right? So upskilling, reskilling is a good time moment, okay? The people behavior, the measuring, because I'm not coming from psychological, I'm not coming from the, you know, the business background itself, you know, talking people behavior. It's a lot of studies surrounding people behavior itself. Now, big data, if you look at behavior, you can capture the big data. That's why you know that they have different level: descriptive, prescriptive, you know, and predictive. Yeah. So you can look at all capturing the people behavior itself. You can look at, you know, look at sentiment, emotional, you know, and then back to this context. So because it's related with the data itself. Okay. Hopefully I can answer the question, but if not, if you have any questions, so I'm more than happy to share about my WhatsApps as well as my email address. So it is good opportunity if you have any question. And currently I'm supervising six PhD students, but 2 PhD students nearly completed. So yeah, so who knows, Indonesian scholar would like to do doctorate degree in the other supply chain, logistics, big data, supply chain 4.0. This is something, a new cluster in my school. I introduced supply chain industry 4.0. Okay, in terms of so many areas in under supply chain 4.0. Okay, thank you once again. Now I go back to your moderator. If any have any question, I'm more than happy to do that because they have time to join the conference.
Okay, thank you very much, Professor Feriji, once again.
You're welcome.
I really enjoy your presentation, your explanation. I believe not only me, all participants here learn something new. And also you offer us to do some collaboration, not only about the topic in this international conference, but also future research, future work.
Yes.
As you mentioned in your list before. Okay, thank you very much about that. And
you're welcome.
And let me close this plenary session. Hopefully, the main objective in doing this research, namely to establish an exchange forum between academicians, can be successfully obtained. Okay, thank you very much. And as a moderator, I'm really sorry about the time exceeding. Okay.
No problem.
Thank you very much. And I give the token back to the MC. Please, Miss Indira and Mr. Furkon.
Thank you to Associate Professor Ferry G. and Doctor of Engineering Erwin Widodo. That marks the end of our plenary sessions today.
Now, we are going to invite Dr. Nur Hadi Siswanto as the Industrial and System Engineering Head of Department of Institut Teknologi Sepuluh Nopember and Dr. Ratna Purwaningsih as the Industrial Engineering Head of Department of Diponegoro University to announce the best paper in the conference.
This is very exciting. Good luck to all of the participants. To Dr. Nur Hadi Siswanto and Dr. Ratna Purwaningsih, the time is yours.
Okay, let's continue with the next session. Good afternoon, ladies and gentlemen. Every research paper submitted to IConISE and ACISE 2020 is reviewed by 2 blinded reviewers. The paper team has been trying to maintain the fairness of the evaluation process by not assigning to the reviewers who came from the same institution within the authors of the reviewed paper. The best papers are selected based on the highest review score. The committee has selected 5 best papers to be granted the Best Papers Awards. Without further ado, Dr. Ratna Purwaningsih and me will announce them. You may start it now, to Ratna.
Thank you, Pak Nur Hadi. The best paper was awarded to paper number 159, author Wahyuda. The title, Development of a Multi-Excellent Economic Dispatch Model for Combined Optimization between the Production and Distribution Side of the Electricity, from Universitas Mula Warman, Indonesia.
Okay, and the next is paper number 132 of Michael Young with the title, A Safety First Portfolio Selection Framework, Estimating the Return of Exchange Traded Funds Through Regression Analysis, from Mapua University, Philippines.
Next, best paper awards to paper number 98, author Ari Triwibowo, Init Indah Arvitrida, and Erwin Widodo. Raw material order allocation problem using mixed integer linear programming and simulation, from Institut Teknologi Sepuluh Nopember, Indonesia. Big applause.
Okay, and the next is paper number 26 with the author Fermi Dwi Wicaksono, Yusri bin Arsad, and Bun Cheong Chiu from University Technical Malaysia, Malacca, Malaysia, with the title, In the Search of Oil and Gas Incidental Cost Factors, the Gaussian Fuzzy Analytic Hierarchy Process Approach. Give applause to the paper number 26.
And for the last, best paper is paper number 81, author Amelia Santoso, Juniarto Parung, Gina Natalia Prayogo, and Winardi from Universitas Surabaya, Ubaya, Indonesia, with the title Designing Cluster of Distribution Area and Delivery Route for Maximizing Vehicle Utilization and Minimizing Workload Gap and Distribution Costs. Congratulations for all the winner of Best Paper Awards. The award certificate will be sent to the author's email. For your notes, the Best Paper Award will be announced in the conference website after the conference. Thank you for your attention and congratulations for all the best paper.
Congratulations to all of the winners.
That was the announcement for the best paper. The announcement for the other category, best presenter, will be published in our website. Please stay tuned as you may be the next winner.
Now, for the rest of this day, we will have 2 parallel sessions, starting at 12:30 p.m. to 2:30 p.m. for the first session, and the second session will begin directly after the first session. The upcoming parallel session will be the final agenda in this conference.
Now, just like yesterday, we will announce the room for the parallel sessions. Do refer to the link given to you in the information book for the Zoom link. We will begin announcing the meeting room for the first session of the conference. The first meeting room will be about industrial management with Dr. Dia Santidewi as the session chair for this room. The second meeting room will have the topic of supply chain management, which will have Dr. Novi Susanto as the session chair. There's also an invited speaker in this room, which is Dr. Wahyudi Sutopo.
The third meeting room will be under production and operations management topic with Dr. Nani Kurniati as the session chair. The fourth meeting room will have the topic about decision making with the session chair of Zainal Fanani.
The fifth meeting room will be about system dynamics and simulation with Dr. Arfan Bakhtiar as the session chair. Sixth meeting room with Dr. Purnawan Adi as the session chair will be about lean manufacturing.
Next, the seventh meeting room will be about ergonomics, and this room will have Dr. Heru Prastawa as the session chair. The invited speaker in this room is Dr. Rifki Ismail. And lastly, the eighth meeting room will be about eye tracking and virtual laboratory with Dr. Aditya Sudiarno as the session chair.
Those are all the meeting rooms for the first parallel session. Please take note of your respective rooms. Now we're going to announce the second parallel session rooms.
The first meeting room is for optimization topic and will have Dr. Singgih Saptadi as the session chair. Second meeting room is about risk assessment with Naning Aranti Wesiani as the session chair in this room.
The third meeting room will be about quality engineering and management with Professor Dr. Ari Susanti as the session chair. The fourth meeting room is about system analysis with Dr. Henry Suliantoro as the session chair.
The fifth meeting room is about supply chain management and will have Dr. Engineer Erwin Widodo as the session chair. The invited speaker in this room is Dr. Indah Arfitrida. And the sixth meeting room is about industrial management and will have Yusuf Widarto as the session chair.
The seventh meeting room with the topic of technology and innovation management will have Dr. Putudana Karningsih as the session chair. Lastly, the eighth meeting room will have Dr. Nani Kutami as the session chair with the topic of operations research. The invited speaker in this room is Professor Dr. Budi Santosa.
And that covers all the information for the meeting rooms. We remind you again to carefully check to see if you get the right Zoom link for your meeting rooms. Note that the first parallel session will start at 12:30 p.m.
Please remember that the best presenter announcement will be published in our website, so remember to stay tuned. As this is our last plenary session, we would like to thank all of you, all of the participants, speakers, and everyone who are participating in this conference. I am Indira Ardiatna.
And I am Furqan Sandifa. As the masters of ceremony of this year's IConISE and ACISE would like to sign off.
Thank you, and see you at the future IConISE and ACISE events.